This example says give the domain of each rational function. And when you're talking about domain, you're talking about the bottom of the fraction. In other words, the bottom of the fraction can never equal 0. Okay, so we want to know that 7x minus 14 cannot equal 0. We have to figure out what would make that equal 0. Well, you're going to solve it just like a regular problem. We're going to add 14 to both sides. Then we have 7x cannot equal 14. Then we're going to divide by 7. And you find out that x cannot equal 2. Now there's another way to write that. They also write it in what's called interval notation. And that looks like this. It says, okay, we can go from negative infinity all the way to 2 with a parenthesis because that means it can't equal it, union 2 to positive infinity. And that says the same thing. X cannot equal 2. We use parentheses here to show that it can equal everything except 2. Now let's look at part B. Now part B has a squared. So before we do this, we're going to have to factor it. The bottom of this factors into x plus 4. Nope. Wrong. X minus 3 and x minus 1. So I need x minus 3 times x minus 1. And that gives us positive 3 on the end, but negative 4 in the middle if you FOIL it out. Now we're going to take both of those and say, okay, x minus 3 cannot equal 0, and x minus 1 cannot equal 0. So if we take that and we add 3 to both sides here, we get x cannot equal 3. In other words, if I put a 3 in there for x, it's going to make it 0 on bottom, and that's not allowed. If we add 1 here, we get x cannot equal 1. Because 1 will make it 0 as well. Now, when we go to write this one in interval notation, think about a number line. 1 comes before 3. So we would write negative infinity to 1 union 1 to 3 union 3 to infinity. And that's what interval notation would look like. Because if we had a number line, here, this would be 1 and this would be 3. And it can equal everything on that number line except 1 and 3. We would have open dots here. But everything else is okay. So this would be the interval notation. All right, let's look at the bottom one on part C. Now for part C, there is no way to make that a 0. I mean, if you do this, 3 cannot equal 0. Well, it's not going to. There's not a variable there. There's not an x. So the domain for this one would be negative infinity to positive infinity. Every number we plug in would be in the domain. Nothing makes the bottom 0. And on this last one, now you guys, if this said x squared minus 4, this would factor x plus 2, x minus 2. But when it's plus in the middle, remember with difference in squares, it has to be minus. This one will not factor. So my domain is going to be negative infinity to positive infinity. Because if we were to look at this, I'd have to get a negative 4 here to make it 0 on bottom. And anytime you square a number, it makes it positive. We cannot get a negative if we're squaring a number. So there's no way to make that one 0 on bottom.